This is Programming 1, GST 7010, Module 1 Lecture, Intro to Python. Let's get things working. I'm your instructor, Robert Hewlett. You can contact me via the email address below. Whoops. Let's go back to full screen. Had a little boo-boo there. Okay, so the general learning outcome is to master, which means know and understand all content and concepts discussed in lab, lecture, and the assigned readings. The specific learning outcomes, although not an absolute list, right, explain how computers work, hardware and software, list some of the reasons we create programs. Why would you ever want to do this? Explain the art and science of programming, distinguish between programming languages, what makes them the same, what makes them different, how much progress have we made, what is progress? Another question. Describe the elements of the Python language. This language we're going to be using in the course, so we got to start getting familiar with it. And explain how the Python language works. We'll go over a little bit between compiled versus interpreted languages, just so you can see what that flow is. Describe the programming problem-solving process. So this is a process that I use when I first start a coding project, and it's really about getting somewhere to start. What you find is once you get into the data and the specifics of a particular language or framework that you're using, things change, right? But you need to start, and so this is just about getting started. So computers and how they work. Well, computer systems are typically made up of two big categories, and there's lots of division within them, okay? There's typically hardware. Today, in the past, you had to have hardware, at your desk or in a server room or close by your particular agency. There was some room or something in a building, on the same floor as your users where there was a central server. Today, we can have stuff in the cloud. So that gives us a lot of, flexibility and the ability to scale on the fly if we have to, but you still need the money to be able to do that. And of course, hardware is nothing without software, right? And so sometimes software can be the limiting factor. You could have all of these cores in a computer, but your software only uses one. And then that makes it a little bit difficult, right? And so we're going to learn about lots of stuff over the course, but that is the big division, hardware, software. So when we talk about hardware, CPU has been king for a long time, right? Almost dethroned, we can say. But it typically runs all the software, right? The bits, the code that we write that takes advantage of the hardware to get something done. The CPU runs that. And there's lots of layers involved typically, like the OS and then utility layers, and then the software, application software that we typically run on top of all of that. And over time, the progress has been to put lots and lots of different layers in between, right? But GPU is becoming more important. It's important in a lot of areas. Mobile, pretty big there. To have a good response in Android, we call it, so the interface doesn't jank. There's lots of things about that. But having a very responsive touch interface, GPU helps, but if you're going to do any kind of 3D, and if you can do 3D on a mobile device, then GPU is really going to help you out. Otherwise, you'll swamp the CPU cores. GIS, especially with something like Arc Pro. Before products like QGIS do all CPU rendering, ArcMap, ArcScene, that era was all CPU rendering. Before ArcMap, ArcInfo, and that CPU. But now that GPU is more readily available, it's in a lot of tablets, a lot of phones. It's now when you get a laptop, if it's not built into the Intel CPU itself, Iris and that, so a lot of CPUs today have a little bit of GPU on them. Sometimes your laptop comes with a separate GPU card and that. And definitely desktops typically either have a built-in one or a separate GPU card. And it's really important in the GIS and CAD industries where we're, rotating 3D images or working with big LiDAR clouds. And so GPU in our realm, not everyone's, but in our realm, because we do a lot of 3D stuff and we have a lot of apps that run on mobile devices, it becomes more and more important, right? You have main memory, or what people call RAM. In servers, this is flexible. How much can you get into the box? If you have a desktop and you built it yourself, then you may be thinking of an upgrade someday. Even a laptop, depending on the manufacturer, some of them are easy to get into a memory upgrade and that sort of thing. These sort of things that we can change. We can even change GPU, but CPU is a little bit different. We don't change that as often. But it is volatile. So but it's fast, right? Is it as fast as CPU? No, in that. And it gets into all these trade-offs of cost and that sort of thing. So main memory is volatile, which means that things we do in there aren't saved. So if the power goes out, whatever we were doing in RAM, typically gone, right? And so when we have a software program on disk, like ArcMap or ArcPro, or even VS Code, those had to be loaded into RAM off of disk so that we can use them and interact with them. And they get loaded into memory. However, we need to save our work eventually, and that's typically done on secondary storage, right? Could be internal or external in that, but this is where we persist data. So if we're going to capture data, write code, write a document in ArcMap, in ArcPro, in a project, make feature classes and that. Well, when we capture that data, we need to store it somewhere. So it's really important that it persists, otherwise it's lost. And so this secondary storage is about persistence. It's about not being volatile. It's usually, a magnitude of 10 or 100 more than RAM in that. So in the typical today, we could get 8 gigs or 16 gigs of RAM, and we might have a terabyte hard drive in a laptop. So lots of secondary storage space. Typically a lot slower. With SSDs, things are better, much faster than rotational drives, but it's much slower, but that also means cheaper, right? So, and again, trade-offs, right? Now, also, there's different ways of getting input into the device, whether that be a laptop, desktop, server, tablet, phone, in that. And think of the Internet of Things. There's devices now all over our house. We have smart thermostats, smart lights. A lot of us have routers, we might even have webcams and that all linked together. And those are all input, okay? So typically old school, there's the keyboard that's always been there. Then the mouse came along and maybe a puck if you're digitizing on a big tablet. Now the screen is a major input device. All my kids are, immediately think the laptop is a touchscreen, and it's not always. It all depends. And the devices have lots of sensors in them, gyros and that sort of thing. And it all depends what was jammed into the device. GPS sensors, right, for location. So lots of different sensors today in your device. Okay. And then output, the classic would be right back to the screen. And that happens on your phone and mobile. People are always looking down at their phones and tablets to get the output of their app. And that printer is another big thing in GIS, plotting out large scale maps, small scale, I guess, actually. But disk, in case you want to save things, right? Also, haptic feedback. Anyone using a game controller knows it can vibrate. Now your phone can do different types of vibration. They can also do sounds and bells and whistles and those types of things to get your attention. And that's all a way of doing output to make the user aware of something. Okay, there's software in that. And so the operating system and related programs that manages the CPU and I/O devices. So there is this layer on top of all your apps like ArcMap underneath that manages the mice and the drives and the RAM and that. And so that's called typically the operating system, right? Who's allowed the CPU, use the CPU and how much, and who goes to the GPU to get something done in that. And also their abstraction. And we live in a world where a lot of stuff is virtual, so virtual machines, and so the hardware is shared. But the software thinks it has its own CPU and its own drive, but it's shared with a bunch of other machines at the same time. Typically, there's utility programs, theft protection, malware, virus scanning, backup, zip utilities for zipping and unzipping. There might even be utilities for doing remote connections like PuTTY or the remote desktop app for connecting remotely to the desktop of another machine. Of course, then there are applications like LibreOffice, PostgreSQL tools, pgmin4, and that PG Modeler, VS Code. You'll be using a few of these in this course, and some of these other products and other courses that I'll teach you. But those are typically where we spend a lot of time. We spend a lot of time up in this application tier, right? Every once in a while, we have to jump down to the operating system to get something done, or use some of the utility programs to zip something up. But every day for us, we're up in LibreOffice, Postgres, PG Modeler, VS Code, maybe ArcPro, right? And also the programs that you write are up in this application layer, right? There is a ever-growing, ever-shrinking category. We have lots of debates about this. Middleware, stuff that sits in the middle that helps. Like I said, over time, we have all these different layers that we add. So, and they've grown to be quite significant, some of these middlewares. And so we can have stuff, lower level stuff, open database connectivity, database connectivity, or maybe even middleware like servlet containers, which run things like ArcGIS Server, or the portal, which would be ArcGIS Online running on your own servers, right? And typically through those, from a GS perspective, what we see a lot of in terms of middleware, we see these web services, web mapping services, web feature service transact, web coverage services, web processing services. So I want to wrap it up there. Just a little test of how this would work with the green screen.